To get into more detail about why IPv6 is necessary, let's take a look at a photo. So who exactly are these smiling people and what kind of ceremony are they attending? Well, as it happens, these are the directors of the various REIRs, or Regional Internet Registries, as well as the head of IANA, the Internet Assigned Numbers Authority. This is back in January of 2011 when IANA handed out the last 5/8s of public IPv4 address space, one to each of the REIRs. So who are IANA and the REIRs, besides the worst band name of all time? IANA is the global authority tasked with managing Internet numbers, including allocating all IP space, both IPv4 and IPv6. But they don't just allocate addresses to anyone. Rather, IANA allocates addresses to the REIRs to be distributed to large organizations as well as ISPs, who then reallocate them in smaller portions to their customers. And as you can see, each REIR is responsible for allocating IP space to organizations in a particular geographic region. The REIR for North America is ARIN, for Europe it's RIPE, Africa has AFRINIC, Asia APNIC, and Central and South America, including Mexico, LACNIC. So when will the REIRs run out of IPv4 addresses? As it turns out, all but one REIR already has. APNIC, RIPE, LACNIC, and ARIN have all formally announced they have depleted their supply. The first three of these have an emergency supply of IPv4 to provide a one-time allocation of no more than a /22 to a requesting organization. Remember that a /22 is 1,024 addresses, so not very much to work with for an organization counting on a fresh supply of routable IPv4 addresses. Meanwhile, ARIN does not provide any emergency allocations. In the meantime, adoption of IPv6 is really starting to take off. This graph shows the percentage of global internet traffic to Google arriving over IPv6. Notice that the amount of IPv6 traffic measured by this graph has doubled in less than a year. Cisco has predicted that global IPv6 traffic will exceed 50% by 2018. So in less than 3 years, IPv4 will very likely become the legacy internet protocol. In the United States, the current percentage of internet traffic reaching Google over IPv6 is over 21%. So how many people in the US are using IPv6? Well, with a total population of around 323 million and internet penetration upwards of 70%, the US has approximately 226 million internet users. Based on the Google statistics, 21% of these users are IPv6 enabled, which means that there are nearly 47 million people in the US using IPv6 today. Of course, nearly all of these users have no idea that they're IPv6 enabled, and that's by design. One critical factor that has driven IPv6 adoption to this point is the rapid acceptance and adoption of IPv6 by service providers. Here in the US, mobile and fixed broadband internet providers have significant levels of IPv6 traffic, in some cases over half of their overall traffic. This should come as no surprise given that these service providers must have an abundant supply of unique network addresses in order to add new customers. As we'll see, IPv6 offers an inexhaustible supply of unique, publicly routable network addresses. Unless you are just rescued from a desert island, you've likely been hearing a lot about the Internet of Things. Cisco predicts that 50 billion total devices will be connected to the Internet by 2020. Without IPv6, there'd be no hope of manageably getting these devices online. Beyond the tablets, smartphones, laptops, and network gear we already know about, what constitutes the things in an Internet of Things? Well, it will include utility company distribution components like smart meters and grids, smart homes with network-controlled lighting and HVAC, home appliances, sensor networks for industry, automotive, agricultural, and infrastructure, medical devices including wearables, and even perhaps biochipped animals. IPv6 will also prove critical to the continued scale and operational agility of cloud computing. It provides sufficient addressing and enables cloud providers to rapidly provision and deprovision any number of virtual servers. It provides enhanced auto-addressing. Provisioning of virtual servers is better facilitated by multiple auto-addressing mechanisms, including SLAAC, as well as stateful and stateless DHCPv6. And finally, improved management of Layer 2 to Layer 3 mapping. Address resolution protocol on IPv4 is replaced by neighbor discovery in IPv6. Neighbor discovery's use of multicast as compared with broadcast in IPv4 is much more efficient and preserves land resources. This is likely to benefit hyperscale cloud computing environments. We'll be learning much more about these aspects of IPv6 in later segments.